how a big chunk of my time every day is spent on security, when it's not the team I belong to. But, there's a separate team, not under me, but security is a big issue. So that has a piece of the pie in DevOps too. And finally, the promise I made in the title I sent you earlier, Bonnie, is to relate it to academia. What can I'm going to give suggestions. That's personal opinion of things that can be improved, maybe in courses, in the curriculum, in approaches, whatever. And maybe you're doing some or all of this. I don't know, because I never took the time to feel the courses and see what you teach. But there'll be something for somebody. So we'll start by talking about what DevOps is. Well, as the name indicates, there's a development part, and then ops is operations. Okay. So the combination of those two terms, development operations, is DevOps. The promise of DevOps, generally speaking, is to remove the silos. What are the silos? Back in the days when most software development was waterfall model. From design, code, deploy, it took months to produce something to production. And there's so much documentation, heavy coding, and at the end, if it failed, what do we do? Well, it took longer to go back and harder to fix. And for those who have taken software engineering, they know about the waterfall model. It's dated, it's not being used at all anymore. More advanced development methodologies like Agile and Scrum are in use, and these endow DevOps way better than the waterfall model. You cannot use the waterfall model. So what are the silent teams? You got developers sitting here developing, and there's the wall, and there's operations here, and they take once to write something, and they send it over the wall to operations. They say, hey, deploy it. Well, you got probably a book-long deployment plan. Operations has to sift through that to deploy the code, and we don't know what's going to happen. It may work, may not.
to represent your screen.
Okay.
Sorry about that.
No problem. Share. Window. Okay. All right. We know if that works.
Work?
Hope so. Is it working? Okay. So. We good? Okay. Should I continue?
We're good, please.
Okay.
Sorry about that.
That's okay. Technical difficulties always. All right, so it allows incremental features to be added, and then it's often combined with the Agile Scrum software development methodology. Probably the perfect fit. Okay, and this is the silos I was talking about. Development, throwing things over. There's no collaboration, no communication, no feedback, no feedback sooner, shorter intervals. You know, these long intervals are not good. Okay, so you have to define DevOps. I looked and looked. This is comprehensive definition. Let's just read it together once. It's big. It's got keywords somewhere. There are shorter definitions, like the management of development and operations. Done. Okay, but DevOps, one source says, is a discipline rooted in collaboration and communication. So 2 keywords already: collaboration, communication. Made possible by removing perceived barriers. Remember the silos? Okay. Between teams and building trust in a culture. Keep an eye on this word culture. I'm going to talk about it a lot. Of learning and continuous improvement. Continuous, there's some automation there happening. And growing from proven technical and management practices. Things like Agile, Toyota manufacturing, lean processes that work toward a common goal of shortening software delivery cycles and improving the stability of deployments. Okay, shorter cycles, stability. So it's big, a mouthful, but it's comprehensive. It expresses really what DevOps is. Okay? Feel free to ask questions anytime. By the way, this doesn't have to be a straight line, right? Okay. Let's do a brief history of DevOps. It started just around 2008, or 2008, 2008, 2000, roughly about that time. It's a combination of many events and practicing. The lean manufacturing, pioneered by Toyota, which was influenced by the Ford assembly line ingenuity, basically. And the idea was to keep inventory minimal for the manufacturing. To keep minimal orders in a queue, right? You don't produce a lot of things sitting and waiting. And then basically manufacture to order. And then maximize efficiency, produce goods as quickly as possible. So time is of essence. These ideas started trickling and fomenting into DevOps. Also, the IT waterfall model gave way to rapid iterative methods like Agile. Okay? Cloud computing, infrastructure as a service, platform as a service, etc. All these things needed something different to make them work. And finally, continuous integration, the idea is from the 90s, but it made its way into DevOps as well. So all of these things influenced the idea of DevOps. The term DevOps was coined by, first of all, Patrick Devops, and one of the authors of this book. I just put the picture of the book. One of the influential books of DevOps. And there was a famous talk years ago, 2009, I believe. It was titled 10 plus, at that time, that would have been revolution. 10 plus deploys per day. That's unheard of. Deploys were once every, 6 months or, but 10 a day, what? I mean, 2009, I don't know how many of the big technology companies we had back then we had some many, but I'm just saying things have mushroomed and exploded. But that was a big promise. Dev and Ops cooperation at Flickr. It was a talk at some Velocity conference. it influenced Devops to basically create a conference called the Devops Days Conference. I think the last one was in 2018. I don't know if they have more since then. But then that's kind of considered the genesis of DevOps, okay? The term and the idea. Another influential book, this is fun to read, the Phoenix Project is called. It was a significant moment because it kind of creates a fictional situation where some managers, IT managers, stressed out about a deployment, mission critical deployment, and then there's some character that narrates things to him, basically DevOps stuff that causes. It introduces DevOps in a fun, novel way. And so it's fun to read if you're ever curious about DevOps. But basically, it introduces new ways of thinking about IT and application development, okay? And these are a couple books if you're interested in. Now, that reminded me that maybe we should remember a little bit the Agile Manifesto. I don't know how many of you have studied that in software engineering courses yet, but if you haven't, it's a bunch of, let's say, software engineering gurus got together years ago and devised this manifesto. Let's read it together. This is the manifesto. It says, we are uncovering better ways of developing software by doing it and helping others do it. Through this work, we have come to value. Look what they value. They value the things on your left, by the way, more than my left, your right. Okay? They value individuals and interactions over processes and tools. Notice the collaboration, the people in DevOps. Working software over comprehensive documentation. Now, I know in software engineering programming, we used to stress so much about documentation. You know, if we have a hello world program, 5 lines, you get 20 lines explaining, you know, where you were born and, you know, your shoe size. We don't need this. Documentation is good, we need it. I'm just saying, let it be proportional and meaningful, okay? So, customer collaboration over contract negotiation. Instead of this big fat contract, oh, this is what you need to deliver by this deadline. Well, the world has changed. Now we sit with the client, the customer. Often, they are stakeholders. They have an interest in telling us what they want earlier, and where they could signal problems earlier, test earlier, give feedback earlier, therefore we produce better software faster and better, right? So customer collaboration, finally responding to change over following a plan, okay? In other words, we don't follow a rigid plan. It always can be, it's malleable, it can be changed. And that's the essence here, is that we do it incrementally, and we have the opportunity to change things earlier in the game than when things are finished, when it's too late. Okay? That is why there is value in the items on the right. We value the items on the left more. That was the Agile Manifesto. That influenced DevOps a lot. Another, I don't know if you've seen this, but principles behind the Agile Manifesto, they're like about 12. But I'll just pick keywords. You got satisfy customers early, continuous delivery of valuable software, welcome changing requirements. Remember, requirements were set in waterfall model early on, and they're like in stone. Okay, deliver working software frequently. Okay, a couple of weeks to a couple of months. Well, yeah, when you have sprints in the Agile Scrum model, they're usually 2 to 4 weeks. Sprint. Every sprint will deliver something at the end of the sprint. Business people and developers must work together daily for the project. See, this is the collaboration between the stakeholders and the IT folks. Build projects around motivated individuals. Okay, basically endow them. Most efficient method within the development is face-to-face conversation. It encourages interaction. Working software is the primary measure of progress. Working software. Agile processes promote sustainable development. Continuous attention to technical excellence and good design enhances agility. Simplicity, the art of maximizing the amount of work done is essential. Self-organizing teams, that's one feature. And then at regular intervals, that's important, team reflects, that's the retrospect. When the team meets to look back and see what they've done wrong, what they need to do better. Okay? All these factor into Agile, into DevOps. Okay? So, top-level benefits of DevOps are speed and rapid delivery, reliability, scalability, improved collaboration, and security. We'll talk about security a little later. Any questions so far? Okay. The business case for the DevOps, why should businesses adopt DevOps, right? Well, this is another interesting book, Accelerate the Science of Lean Software and DevOps, Building and Scaling High-Performing Technology Organizations by Nicole. Yazambo and Jean Kim are two of the leaders in the DevOps world. I want to highlight their findings, basically. The first one is, their research found that high-performing DevOps teams were, when compared to low-performance, were 46 times more frequent code deployments, 46 times, 440 times faster lead times from commit to deploy, the commit the code to deploy in production, 170 times faster mean time to recover from downtime. So failures are dealt with better in a shorter amount of time, and 5 times lower change failure rate. When system changes happen, it has an advantage, okay? So these 4 key metrics span the entire pipeline, revealing, and I highlighted the keywords here, both accelerated development and operation stability. Operations and development, they're not at odds with each other, okay? They used to be a side of it, okay? So this is important. That's the case to sell it to the business world, okay? Now, some of the DevOps practices we're going to talk about: continuous integration, continuous delivery, microservices, infrastructure as code, monitoring and logging, communication and collaboration. I can't talk about all of them, but I picked a few that I think are important, okay? The Cicd pipeline. You probably started seeing this late the last few years more and more. It's all about automation and continuous deployments and delivery. Okay? The D is, CICD, sorry, not CICD, I just noticed. CICD. Okay, it's a DevOps must. See, I fixed it. Okay, so if we look at continuous integration, plan, code, build, you send it to testing. I'm looking at the little infinity here. Release, deploy. See, this side is operations, and that side is development. Somewhere kind of in between is like testing. There should be security too. The security is all over the place. It's not left or right or middle. It's everywhere. Okay. So basically, it's about continuous integration and continuous delivery. It's at the heart of DevOps. And what does an automated pipeline do? It enables you to eliminate errors due to manual task execution. And I cannot tell you how many times they've sent us, and I've done deployments for operation for developers, and they'll send me this Word document, text document, Word document, with steps in it. And if it's a Saturday and there's no developer in sight, or at least the people who wrote the plan, and I have a question, I'm out of luck. And we did deployments on Saturdays, on weekends, holidays, whatever. So I'm reading the plan, I'm like, oops, what do they mean? Oh, this is spelling error here. Do they really mean that? Etc. That's manual. That's error prone. We don't want that. Provisioning of standardized development feedback loops. The feedback, I need to know earlier if it's going on right or wrong. Enabling of fast product iterations. Okay, this is just, I didn't draw these. I took them from sources in my site. But basically, what you have here is there's the continuous integration part and the continuous deploy part, and it starts with the source, build, start testing. Okay, well, hand it to the business tester, the user acceptance testing, basically. Okay, are we good? Are we in pre-production? Okay, go to production. But notice those little detours here. These are the feedback loops. I know from those if something goes wrong early. I don't wait till here to have one feedback loop. I have feedback loops all over the place. Okay? Continuous testing is key across the board. What do you require to enable that CI/CD pipeline? Well, continuous integration, delivery, deployment, monitoring, quality testing, and automation. I think we covered some of those, so I'll keep going on that. But automation is key. We'll talk more about automation. Now, if we impose tools, DevOps tools, actual tools on top of the pipeline, you'll start seeing things like Jenkins. It's very popular in orchestrating the builds and deployments. Probably one of the most popular free tools you could use for if you want to build a CI/CD pipeline. Git repositories, source code version. You got the actual programming language, Java, C, C++, etc. You got JUnit, Conversion Linux, stuff that testing your program. Deploy. Okay, it's good. I'll send it to operate on deploy it. I need a tool to do that instead of the Word document that I talked about earlier. Okay. And then it goes to production, and again, the feedback loop. And then there's a lot of technologies. There's Jira for collaboration. What am I missing? A lot of, you'll see the technology soup. I have a chart where I have, like, it's got hundreds maybe on it. It's too much. You just need to pick a few, okay? So we'll see more of the tools as we go. So here we are. Let's talk about some tools. Here's a few of them that are very popular. Chef, Puppet, Ansible, Docker, Git, GitLab, Azure, okay. Kubernetes, fancy, nice name. Yes.
Proxmox one? Proxmox?
Proxmox? Not familiar, no, you don't know. Do you know what
Yes,
Linux
space. Pretty sure it's similar to Docker.
Oh, maybe you'll find it. I have a big image later on with all of that stuff on. Not all of it, but at least a big chunk of it. Maybe it's there, but I'm not familiar. Okay, so let's talk about version control systems like Git. Okay? GitHub, Bitbucket, we use also TFS. I'm not saying we use all of this, I'm just giving you some of the popular ones. We use some of them. Git is probably one of the most available open source source code control systems. Subversion, there are cloud options. And I put the dog ate my code because we had a case years ago where the developer decided they're putting their code on their laptop, on their machine. That is no. You don't do that. In the real world, you don't put anything because I should be ready to take this and trash it. And I should not lose one bit of data. How? You put it into a source code control system. You check in your code. Check it in. This goes away. So you can tell the developer was in trouble. I mean, I saw him at Taco Bell the following week. No, he was embarrassed. It was bad, but it was a lesson to be learned for everybody. You don't put your code on your hard drive that's about to crash. You put it in a source code control system. Okay, so that's one thing, one tool that's very important. Okay. Containerization. Does anyone work with containers? Docker, Vagrant, stuff like that. They're beautiful, huh? Don't you love them? Docker is one of the most popular containerization technologies. And the idea is, okay, I write code, I want to package it, and I want to send it to you so that you could just plug it in and it works. How do I do that? Well, the questions to ask is, what about the underlying infrastructure? What kind of architecture do you have? Is it little endian, big endian? Is it 64-bit, 32-bit? Is it Spark? Is it Intel? Is it Linux? Is it Windows? This tries to solve some of these problems. You package the software, the key is with all its dependencies in it, in a package called a container. So the container is a standard unit of software that packages code and all its dependencies to run quickly and reliably from one environment to the next. We're going to talk about environments because when we say deploy, what do we mean by deploy in the pipeline? Where am I sending the code? Where does it go? Where? Okay, I could have a server here. So we're going to talk about environments and the importance of development, staging, production. You can't have one environment. The world is not flat. It's got to be staged, right? So I deploy it. Well, that means I'm moving code from one environment to the next. Will it work in the next? The biggest challenge is, are the environments the same? We keep facing this problem every day. It worked in staging. Why is it failing in production? Well, your environments are the same. It should work. This tries to solve this problem. So we package it, we ship it, we run it. A template becomes a container at runtime. So we can only speak of a container really once it is runtime. Where does it run? It runs in a Docker engine. The engine's job is to isolate the underlying details infrastructure from it's not a VM. Don't think of it as a VM. It's really a container. The overhead of containers is so low, it's amazing. Like maybe 1%. It's low. Because what it does, it kind of draws curtains around the operating system. It makes you think you got a machine, but it's not really giving you a new kernel. It's not a heavy system, right? It's very light with the dependencies packaged together that you could move around. And this is good for the cloud. If you want to move your Docker container from, let's say, your laptop to Azure or to AWS, you could request like an elastic instance from ECS from AWS, and that uses Docker. It's not good there. So it helps in that aspect. Leading cloud providers use Docker. I know Amazon and others use Docker. It's fancy, but very, very good technology. And so containerization is important. Okay. Any questions?
About the software.
Yes, sir.
We work with. Is it internal software or is it software for outside clients?
The software we work with. So I'm in operations. Okay. I'm not a developer. This is why I'm not really developing any software, but I deal with developers a lot. And I work on implementation plans for developers. So it's mostly Java. We use WebLogic for middleware to deliver Java applications, Java-based applications. It's Oracle, basically, WebLogic. And we deploy it to which operating system? How many say Windows? How many say Linux? I'm just going to survey. How many say Solaris? Let's start with the Windows. 1, 2, yeah. Linux. 1. Solaris. Oh, 2 Linux. Okay. Don't know. It's the rest of you. Actually, it's Linux. So we're deploying code for the federal government, for the Department of Interior, on Red Hat, using WebLogic as supported. Now, they're all supported products. We can't afford to just download a hacked version of something. They're all supported. We have contracts with Red Hat, Oracle for WebLogic, and Java. We got licensing, etc. But does that answer your question? Is Java, WebLogic for middleware, Oracle databases in the back end that we deploy to Linux servers? Right? Cool. Okay. Another tool for DevOps is orchestration. Well, now you have all these containers. You need something to kind of manage them, spin off new ones. How do you orchestrate all these containers? One, there are many tools, but I just stick to, since we talked about Docker, let's start at the bottom. Docker Swarm is one technology that allows you to define a desired state you want for your systems, and then Docker will maintain it. And basically, it allows the creation of a swarm of Docker engines, okay, where application services can be deployed. Now, suppose you want to scale your app, depending on load or event, and you want to spin off more, like, around the holidays, everybody goes shopping online. How do you think these big companies deal with the search? They're going to have some ways to orchestrate adding processing power to their websites, to their and containerization along with the technologies like Kubernetes, Docker Swarm, and others for the cloud enable you to scale as needed, scale up, and scale down as needed. Okay? Because scale up means you're paying more, scale down means you're saving. Okay? I mean, if you've used Amazon Web Services or anything similar, you know that they're going to charge you eventually if you use certain resources. If you keep it on and you forget about it, the bill adds up pretty quickly. So we start with our costs. Okay? So orchestration is an important DevOps tool. Automation. I would say at the heart, this is really at the heart of DevOps is automation. And we want to eliminate manual steps. There are a lot of automation tools. Jenkins, we talked about it as build and deployment. Very good. Chef, you devise recipes. Puppet can connect cloud providers. Ansible, I'm going to talk more about Ansible because that's something we use every day. And then Terraform. So all these are automation tools. I want to specifically pick on Ansible because I have experience with that. My team uses it every day. We are still trying to encourage our developers to use it more and more, but we're not there yet. It's like moving mountains. So Ansible, until a few years ago, Red Hat purchased Ansible and created something called Ansible Tower. Let me talk about Ansible. It's basically a automation tool. Okay? You write playbooks. Like Chef, you got recipes. Ansible, you write playbooks. The playbooks are written in YAML, yet another markup language. And you specify states or conditions, and Ansible will try to meet them. For example, just to give a simple example, I want to add an entry to my host file on all my Linux servers. Well, if I have 350 servers, I'm not going one by one SSH and VI or whatever editor you use. No, we're going to automate. We write the playbook. I say, here's my set of hosts. Here's what I need to do. Go and do it. It's going to need some credentials, of course, to do it, right? So in seconds, you'll see it shows failures. Done. Now, Ansible's one beautiful aspect is idempotent. Idempotency. Anybody know what that means? I'll be ready to explain it. But idempotency is like functional composition in math. Like f of x is equal to f of x. Meaning, no matter how many times you apply the function on x, you end up with x. What does that mean? It means an elevator button. You press the button on an elevator, people press it more than once, doesn't help. That's idempotency. One press is enough, 10 is the same. Idempotency means if I'm going to change that entry in the host file and it's already changed, I'm not changing it. Done. Once and done. Okay? Does it make sense? Is it clear? So it preserves the state. If the state is good, it doesn't touch. And that's why, because, for example, I could have 10 systems offline when I apply the change, but then I want to catch them up. If I run the same playbook on all 350 machines, only the 10 will get the update, because the others are already updated. And that's idempotency. Okay? A white set has a white set of built-in modules for databases, for Python. By the way, Ansible, you know the beauty of it? You don't need any agents. You don't install anything on the server. But how does it do its work? SSH. You secure shell into the system, and that's in all Linux and Unix flavors, they all have SSH. Second thing, it means Python. As long as you have Python and SSH, you can run Ansible flavors. Okay? Now, Ansible Tower takes it a step further. And it puts a GUI, puts a nice interface, it puts dashboards, roles, like I can assign you. You can restart those servers. You can change the password on this. You can, do database, blah, blah, blah. The roles are important. And then you can watch the project. You schedule tasks. Like at 2 a.m., I want to kick off the patching of all my Red Hat Linux or Windows, whatever. Ansible works on Windows too. Okay? And so it has GUI roles, scheduling, and monitoring of jobs. Any question on Ansible automation? Collaboration and monitoring. I'm not going to talk about these much, but you may have heard SolarWinds is a monitoring software. There was a big hack recently, caused the federal government probably a lot of pain. Supposedly they fixed it, but it shows you how tricky software is. I mean, you deploy something, you're thinking you're fixing a problem, but you're maybe introducing a new problem. But Jira for collaboration, Google Workspace, etc. This is a fuzzy area because, you know, collaboration, there's so many tools, and there's also pencil and paper and email and texting and whatever. Pick whatever works for you, okay? But that's important. And monitoring is important. Monitoring is important because it could tell you earlier about problems, so you could proactively fix them instead of the system degrading into an unusable state, okay? But also, it's good for automated testing also of applications, okay? This is the picture I told you about before. I don't know if you can find the technology. This is probably 5%, I don't know, 5–10% of all the tools out there for DevOps. But the idea is there's so many, and you don't need but a few good ones. And what you need is mentality and culture and the good tools, and then you'll be on your way to implementing a good DevOps approach. Okay? So let's talk about the pitfalls of DevOps. What could go wrong? What DevOps is and is not? Okay. Well, let's talk about what DevOps is not. Remember people, processes, and did I say tools? People, processes, and tools. Let's talk about people. Well, so years ago, we hired one person whose specialty was, how are we doing on time, by the way? But we hired somebody who was like a DevOps person. And then we thought, oh, you know what, we're going to create a DevOps team. And then, so now you have development, you have operations, and then you got security, and now you have DevOps. Well, aren't they supposed to work together? That was a mistake. You don't create a DevOps team. But if you do, it has to dissolve after the mission is done. You cannot keep a DevOps team because you're creating a silo. Okay? So just experimenting with personnel changes or team structure is not in and of itself DevOps. Okay? Just moving people around doesn't cut it. Okay? Some common attempts focus on like hiring DevOps engineers. We did that. Creating a third silo, talk about it. Tearing down the wall literally, meaning like you are here. We'll put the developers physically close to each other, but also figuratively through organizational changes, try to remove the silos between software development and IT operations team. So this is the people element, okay? So just moving around and hiring people doesn't cut it. You need more than that. The process part, some think that DevOps is a complete departure from process. Like, oh, we used to do this, and that. And DevOps is like, oh, you're breaking. No, you're not breaking process. You're refining it. You reimagining the process. You're doing it in a different way. There's still a process which is done differently and better. Okay. Now I highlighted the word cultural change. Interesting quote. Let's read it together. What we see in the market is that our customers' greatest challenge today is often the cultural change required to get all of the process owners to think outside the legacy process box they find themselves in. So years ago, 5 or 6, we started, okay, we got to do DevOps. We got to do DevOps. We got to do DevOps. Okay, how do you do DevOps? Okay, we hired some people. Okay, we got some tools. Okay, what was the number one problem? Getting our managers to adopt it. We met with our program manager. Look, you have to tell development, we're starting DevOps. They gotta adopt them. They gotta change their way. You gotta force it down from top to bottom. You're gonna tell them, starting XYZ, we're using DevOps. You know what happened? They're so busy putting out fires every day, they never made the time for it. It never worked. The first challenge is cultural, people, mentality. Okay? But that has to change first. Yes, sir.
I would like to hear your hiring, the
Hiring process
for DevOps.
for DevOps, like potential.
Right. Personally, I'm going to
Okay.
hiring developers.
Can you save that till the end? Because I talked a little bit about what we need to do in academia to produce better DevOps engineers. And do you mind saving that till the end?
Sure.
Remember to ask it.
I was talking about when you were talking about bringing DevOps from outside.
Okay. In that aspect, yeah. So the problem is, see, like every new technology, you don't have people readily made as DevOps engineers. They organically develop the skills and build it, and then their resume looks like a DevOps engineer. Unless they go take some boot camp for DevOps or spend, several courses of building their DevOps career. So many jobs out there for DevOps. It's shortage, hard to find good DevOps engineer. But we hired somebody who had enough skills, let's say. The person was very good, kind of more, and it's difficult. How do you find someone who knows development, operations, security, and everything in between? It's difficult. You spend a career building that.
So you would not hire somebody from your own development team?
Okay, good question. But now we need to change your mentality of the question.
You can talk about it later.
No, but this is very good. The mentality of the question is like, this is like people change it. We don't want to do that. We want to adopt the culture of DevOps. Stay where you are, but start adopting DevOps practices. How? Well, let's look at how you build code. Do you use source code control? Do you use collaboration? Do you use automated Cicd pipeline? Do you use automated testing? Do you have feedback loops? Do you meet frequently to talk about what you just deployed and assess what went well and what went wrong? Do you have monitoring software? And you go through that. So it's really the cultural change, the mentality. They may have the skills, but people, processes, and tools, all of that has to change. Okay? And so again, we don't want like a DevOps team. That's a mistake. But if you do that, it should be transitional and it should be dissolved at the end. So now we're done with the process. Finally, the tools. It's not simple. I mean, you could get Jenkins and Jira and Kubernetes and then sit and look at them. Okay, what do I do? Well, you need people who know how to use them, how to integrate with your system, and also to automate the heck out of everything. I can't stress automation. So it's not simply just the tools. By the way, the tools may mean different things to different people or companies. Go to Amazon, they'll be pushing certain tools. Go to Azure or Microsoft, they'll be pushing a certain set of tools. It's in the eye of the beholder. That's why from this big soup, you have to pick the best tools for your need, okay? And so basically, tools that enable IT automation are a key aspect of making a DevOps work in practice. Okay, but if the underlying principles and processes are not a part of the equation, tools alone will not do. Okay. So people, processes, and tools, they all have to align in a correct way, in a correct cultural and mental state. And adoption has to be from top to bottom, not bottom. I'll tell you briefly about our successful and failed attempt at DevOps. It started in operations, sadly. We wanted to automate everything, but development didn't subscribe. So we ended up automating the heck out of everything in operations. In fact, almost everything we do in operations is automated. One success story I can relate. When we have hurricanes, disasters, fires, floods, we gotta go somewhere else to operate our system because you know who our customers are? Exxon, Chevron, Mobil, the big oil companies. They need to be able to go in and log some data about oil wells, get lease permits, etc. A lot of regulations and revenue, etc. These websites have to stay up. So we have a disaster recovery site. So when we shut down our operations in New Orleans, we gotta be up somewhere. Well, we bring our systems up in Denver, Colorado. The process used to take about 2 to 3 days to turn on disaster recovery site because the document was several hundred pages long. got it on pages, but it's a big document. To go through it manually and read like this, you could make mistakes even if you copy and paste. Okay, it's a recipe for failure. And you need like 3 or 4 people looking at every command you type. That's not great. So we took all of that and we wrote Ansible playbooks with a pretty nice interface. And we said, all right, we'll activate the web logic, activate this. And then we did it in 2 hours. We went from 2 or 3 days to 2-hour operation. It could be faster, but we work with the government. It's never as fast as you like to be. Okay. So now we talk about security. I highlight the word DevSecOps. You'll see the term also in the literature a lot. And the idea is what happens to security. We never talk about security. Well, you know what? Security should really be inherent to everything. It's overarching, it's everywhere, over, under, above, next, in, it's everywhere. Security starts with coding. You gotta write good code that doesn't do buffer overflows or allow SQL injection or. Coding, that's where it starts. Then it goes on to deployments, the vulnerabilities of systems you deploy it on, the firewall, a lot of aspects of security. Okay, so security influences DevOps a great deal. Here are some of the activities, security-wise, that could influence DevOps. For example, or in general, these are security activities. And by the way, if you're thinking of a career in security, you'll find a good job. Good security professionals are in high demand also, because I know we have a security team, and we know the skills we look for. And it's not just use a tool and point and click. I want the security person to understand operating systems, data, not to the fullest, but some databases, operating system, storage, firewalls, switches. You cannot be a security person just by using a tool. Okay? But some of the things we do is continuous vulnerability scanning. For example, this machine is on the network. Is someone checking if there's a vulnerability on it all the time? Is it done daily? This one? Okay.
Yeah.
Representing the screen.
There
Okay.
you go.
Back to business. Okay, where was that? Here. Talking about security. Any questions about security? Okay, so we'll go down the list quickly because I think we're running out of time. Security technical guides called STIGs are a very big deal. They are the guidelines on how to harden a system that could impact your DevOps operations. Application firewalls. You know, when you connect to websites, nowadays, you don't go really directly to the server. You go through an application firewall, and that redirects you to the real server, which is masked from you. That's for security reasons. You should never know the server in the back end. Right? And web application scanning, you deploy, even in your development pipeline, you deploy something, well, you should have automated testing. Part of the automated testing is to run web scans to see if your application is vulnerable for things like SQL injection, buffer overflows, and the like. Principle of least privilege, only give the permissions needed, no more. That's very important. Build security into your code, we talked about that. And then it should be really a part of every step in the pipeline, not an afterthought. Security should not just be, oh yeah, let's do security. No, you should be doing it all the time. The impact of security is that it forces you to have separate environments. Again, we said you're deploying where? Well, you're going to deploy to an environment. Typically, you should have a development environment, a staging or user acceptance testing environment, a production environment, and then when you're interfacing clients outside like we do, we have to have some demilitarized zones where it's hard to reach those systems. They're so tight that, you know, if the oil company comes in and I need to talk to that server, I want to minimize the chances that a hacker will get into this AIZ or DMZ zone and then get into my internal network. It makes deployments more challenging, but it's a fact. If you go to the real world, you're not going to have one flat environment. You need to deal with security issues at times. Okay? Maintain separation of duties. Developers should never be working anywhere but in development. In fact, we have separate even active directories for development and for production. Okay? We don't mix the two. You got to draw the line. Okay? But then you're deploying across, right? So there's security challenges. Okay, let's start with bridging the academic industry gap. I'm going to make 8 recommendations. Okay. And I'd like your feedback to tell me if you already do this or not. Okay. So first one is create multiple separate environments. You do that? You have? Yes, you do. What I'm proposing though is like maybe in your next iteration of a lab, it could be as little as buying a smart switch with VLAN technology. And you decide, all right, these segments are deployment. This is, development. This is staging, production. Play the real world. Play development, staging, production, because if you train your students to think that the network is open all the time, and as the Wild West, it is not. You'll be shocked. Okay? So this is, and this is supports CICD. You cannot have CICD with it. If you have it in a flat run environment, it's meaningless, because that's not how the real world works. Okay? Second recommendation, create and utilize the CICD pipeline. So basically, segment the network, separate development from staging from at least 3. Development, you can get away with 2, but staging is important because that's where user acceptance testing happens before it's approved for deployment finally to production. Create and utilize that pipeline. If you start training your students from day 1 to check their code into a Git repository or Subversion, one of whatever, Bitbucket, anything, that's a good practice. Then, no code on your laptop or local machines or your thumb drive. But it's okay, take it temporarily. But I'm saying the main code that you check in should be in a version control system. Stress the use of automation for builds, deployments, and testing. CI/CD is all about automation. Teach them Ansible. Teach them all these technologies. Use Agile Scrum methodology. I don't know if you, is the methodology used in your, okay, that's good. And consider test-driven development. Now, this may not be practical for a lot, but the test-driven says basically create the tests first and work towards them succeeding. In other words, start with nothing, a test that fails, and then work into making the test succeed. That means you're building software to fulfill the test, right? That's test-driven development. So that's number 2, Cicd Pipeline. Assign real-world projects. I know we used to give toy projects, especially for intro classes, which I understand. But as students move up to senior levels, we cannot afford to give them toy projects anymore. They gotta be meaningful. They gotta have a database back end. Give projects that use a database back end. And projects that don't use data are almost meaningless. I mean, you could write a program to do what? It's all about data. Teach them to connect with Oracle databases, SQL servers, whatever. Databases, MariaDB, pick a database. Use containers. Containers are beautiful because then you're teaching your students to package their software into portable units that can go from development to staging to production through deployments. Okay, it's beautiful. It also enables you to go to the cloud if you decide to experiment with any cloud options. Teach Linux. I'm biased because you don't know. I made a career out of knowing Unix. In 1995, I believe, I created, I could be wrong, but let's say 1995, I started a course at LSU to teach Unix. There was 2 credits out. But you won't believe the students who took my course and finished it, how good of a job they got because they knew Unix. There was no Linux at the time. It was BSD or Solaris or OS F1 or something. It was Unix. Nowadays, Linux is the most prevalent X flavor. So I don't know. Do you have any courses where the students get exposed to Linux? Like where? Okay, there is a course for that? That's beautiful. Absolutely. So that's great. That's good news. So if you use, if you learn enough Linux, that's a good asset for the DevOps world. Okay, you cannot let your students go without knowing some Linux. Okay? Or any flavor, Red Hat, SUSE, CentOS, whatever, but some Linux. Teach and practice security. We need to practice what we preach and teach what we practice, I guess. Whatever you can, but it starts with coding. It starts with the security of the system you're deploying on, the firewalls, everything. It's layers and layers of security, okay? You can secure your bathroom, but if your house is vulnerable, we'll secure the house. All right, we'll secure the neighborhood. All right, we'll secure the city. But every aspect can have security, okay, all right? So security is very important. You should know something about security. And number 7, have teams play Dev, Sec, and Ops. And what I mean is, in this permutation of A, B, and C, every team will get a chance to be Dev, Sec, and Ops and you can decide if it's one course or what. But let's say you have a course and you want to do Dev, Sec, Ops. Now you can divide it, 3, 3, 3. You play Dev maybe for 2-3 weeks. You play security, you play Ops, and you permute, just an idea, to get the students exposed to what developers do in a DevOps world, what security does, and what operations people do. Okay? And finally, maybe it's time for a DevOps course or seminar. I mean, look, when web services were becoming hot, I gave a course at Loyola, Web Services. When I got there, they were programming in .NET, Visual Basic and stuff. This is fine. But I'm like, you know what? Let's start our programming courses with JavaScript. By the way, that's very hot today still. And guess what? We did it in a web-based context, in a browser. We wrote code, the browser interprets beautifully. You don't need compiler or anything. But you learn programming through a beautiful interface. And so I created Internet Technologies course. So you have to adapt, of course. I'm glad to hear the sysadmin because I'm biased because I've been sysadmin for all my life, so that's good. It could be a seminar, it doesn't have to be, maybe every couple of years. There's a lot of material to teach, but we got to start somewhere. Okay. And finally, it's safe to say that DevOps is hot. It is hot. You find good jobs if you know DevOps skills. DevOps adoption may be tricky, as we have seen. A lot of tools to choose from. You only need a few good ones. It is fueled, the surge in DevOps requirements fueled by cloud technology also. Automation, keep that in your mind, is at the heart of DevOps. Learn Ansible when you can, and other automation, but Ansible will probably get, when I've interviewed, you don't know how many people in the last few months. We're looking for good Linux sysadmin, we're looking for a VMware administrator, and I never fail to ask the question, do you know automation? Do you know Ansible? I want to see that on the resume. And security, don't forget about security. And then, as we just mentioned, academic programs have to tweak themselves a little bit, think outside the box, implement DevOps when you can, and because that will get your students very good jobs. And at that, I'll say thank you, and we can do, if we have time for questions, I'll be glad to take some questions. Questions? Is it informative? Yeah. Sir.
Talked a lot about making sure the DevOps, the development, the deployment, it all works together. Right. What is the interest in necessarily ever having these as separate ideas? Because I feel like you should build software to be deployed.
Right. And that's been the case from day one. You build software to be deployed, but the problem was it was heavy. It took months to build. Of course, go back to the 80s and 90s, we didn't have all the tools we have today, the luxury of just everything at your fingertips. And software engineering was a science, developing like everything else, like AI and the theory of computing and operating systems. And you get all these big gurus in software engineering. And, if you look back at your papers, in the 90s, I don't know if they're still relevant today, but they were relevant at the time. So the field was evolving, and we got to this today. Now it's like de facto doing Agile and Scrum and things like that. But 15, 20 years ago, it was the heavy waterfall model, and delivery was slow, heavy, took months. These ideas from Agile, the manufacturing, the lean manufacturing, they were fomenting, they were building up, and then finally the idea of DevOps, coupled with Agile and other technologies, allowed us to do things better. So everybody wanted to deploy. It's just the tools and the ideas. We're learning as we go. Things are improving. So it's a learning process.
I have a couple of questions.
Please.
In terms of security, do you use any sort of penetration testing or the tool that is used? Is it involved in the DevOps?
Yes, now it is involved indirectly in a way because, as we said, security is everywhere at all levels. So what we have, every day I get some spreadsheets or emails or task that says, you got a vulnerable Tomcat version on that server. You got TLS 1.0 enabled here. You got this. We get a list almost daily. I'm telling you, security takes more than half of our time nowadays. So there are automated tools that they have scheduled scans. Now, for example, if you do plug something into the network, it's supposed to be detected as an unapproved device. That's intrusion detection. And it will block it where? Of course, I don't have a robot to come unplug it. It's going to block it where? At the switch level. This level, the switch has intelligence such that, that device is not on the whitelist. Don't allow it. And same thing for viruses, vulnerabilities. Every day we got CVEs that come out saying, this version of WebLogic is vulnerable, that version of Apache. We have a problem with TLS. It's a continuous battle. So that is a continuous and continuous scanning. You have to continuously scan and monitor your assets and networks for intrusion detection, vulnerabilities, Compliance. We get scored. The system has a score. Ideally, it should be 100, but it's almost never 100. But if you fall below a threshold, we need to explain why the drop. It could be a configuration change that lowered the security profile of the machine. The score drops, that's a flag, right? All of these. Did I answer
Is there like someone that
Absolutely.
purposely tried to
Yes, every now and then we get social engineered. Somebody will try to do phishing on us. Somebody will give us a call, pretend that they're gonna change our passwords and whatever. So the department plays, hacker, I guess, ethical hacker, tries to see the vulnerabilities in the system. So yes, they do that periodically, and they do auditing also. It's heavy on audit. Every now and then your systems need to be audited for your security practices. Did it answer your question?
Yeah.
Okay. Any more? Yes, please.
Well, it's unrelated. The waterfall method, I don't know, I've never worked in a Microsoft or whatever, but is the operating system, is it the waterfall method still used somewhere?
The wormhole?
Yeah, the waterfall that you mentioned? Yeah.
Did I mention wormhole?
Waterfall.
Waterfall?
Yeah.
The waterfall.
Waterfall.
The software
Yeah,
development.
Yeah.
Oh, I'm not aware. I don't think. I mean, unless you're still programming in COBOL.
I'm just saying because the operating system, they just like release new versions every once a year.
Right.
It doesn't seem to be like.
It's really independent of the OS. I mean, if we're talking the waterfall, the software development model, that's archaic. That's just not. It doesn't fit anymore in a fast, continuous world. You need something better. Yes, sir.
Think of automation software, the UI map, and interaction.
Automation software to do what?
Like RPA, robotic process automation. So UI map, automation anywhere, Microsoft's automation suite.
I'm only familiar with automation when it comes to IT operations. Now, automation is everywhere. I mean, I'm sure if you go to a manufacturing plant, you're going to find automation software all over the place and hardware. But, and it's growing on Devops, right? So yeah, I'm not familiar with the particular systems you mentioned, but definitely I'm all for automation. You get it right, it saves you time, it's good investment because it's repeatable. You devise a deployment plan, you write a playbook for development. It'll work in staging, it'll work in production as long as the environments are simple. Okay. There are changes that need to be done for each environment, especially for databases, because the databases aren't the same in the environment. Okay. I hope you benefited from something. Thank you so much. Enjoyed it.
Thank you so much. So thank you guys for coming. I'm so excited to see so many students here today, and we have students online as well. I'm really encouraged because your suggestions coming from industry, we do. That's one of the things our department has been really good about. This is part of what we call our Industry Connect initiative.
Great.
We have an industry advisory board, and it's just to make sure that we are doing those things, the things that industry finds valuable, so that our students are then able to step out of the academic world when they graduate, go straight into a great job and have those skills through our real-world classes. So that was very encouraging to me.
Yeah,
that was encouraging.
That you're doing some of that, and that's my perspective from what I do. If someone else from the industry comes, they may add to this or say, oh, well, we encourage this too.
Yeah.
So it's not just Java and Ansible and WebLogic, and there's a lot out there, but these are major forces to stay.
So thank you so much, Elias. I appreciate it.
Thank you. I enjoyed it.
Appreciate all of you, and
coming.
we will continue our distinguished lecture series in February. So hope to see everybody in February. Thank you.
Thank you. Thank you. Good. Thank you.
Thank you.
Thank you.
Where's the company, where's it based on?
with the NTT?
I work for NCT Data Service. It's a worldwide company. It started in Japan, Nippon Telephone and Telegraph Company, and it grew into big acquisitions. It became an IT firm, mostly contracting, federal government, and others. So it's the headquarters. I don't even remember where that is.
Thank you.
Thank you. It's probably up north somewhere. Okay. But it's online. You get jobs all the time. You know, for graduates of IT world. Keep an eye on entityData.com. So yes, it's all over the world. It's so big actually. But we're with the federal arm.
Not quite sure what I want to do.
You graduate?
Yeah, I'm going to graduate next semester. Might be system administration, might be go my app idea and do web development.
Okay.
Kind of keeping the door open